In this section, we'll learn about the linked list data structure, which is a basic but very important data structure. And most of the questions in technical interviews are based on linked lists. So it is very important that you understand this concept properly and are able to write the code on your own. Okay, so now let's start. We have seen the list abstract data type in the previous section. It can be easily implemented using arrays. In Python, we have the list data type, which is an array-based sequence. So we can easily implement this list abstract data type using the Python list. Another way to implement this list abstract data type is by using linked list data structure. In a linked list, data is not stored in contiguous memory locations. This is an example of data stored in an array-based sequence, and this is an example of the same data stored in a linked list. This data is stored in contiguous memory locations, while this data is scattered here and there in memory. Here the list items are stored in sequential locations, so the relative positioning of list items is implicitly maintained. We know that this is the first item, this is second, and so on. In a linked list, the items are not stored in sequential locations, so the relative positioning of the list items is maintained with the help of links. A link is a reference to the next item of the list. So we have these links here. Each link refers to the next item. So with each list item, a reference to the next item is stored. Now the list item together with the link is called a node. So these all are nodes. These nodes are the basic building blocks of a linked list. The nodes are connected together by links and they collectively represent the linear order of the list. So this first node contains the first list item and reference to the second node. This node contains the second list item and reference to the third node, and so on. We just have to know where the first node is. All other nodes can be found by successively following the links. From first we can go to second, from second we can go to third, and so on. So while implementing a linked list, we maintain a reference to only first node of the list. And with the help of this reference only, we can access all the elements of the linked list. We'll call this reference start. So what is a linked list? It is a dynamic data structure that is made up of nodes arranged in sequential form. Dynamic data structure means that we can allocate the required memory while the program is running. A dynamic data structure can expand or shrink easily during runtime. So a linked list does not have a predetermined fixed size. It does not reserve any extra space in advance. It allocates memory for the next item as and when it needs it. In the case of array-based sequences, the size of the array might be more than the actual number of elements that are stored in it, resulting in wastage of space. Now for array-based sequences, we need large chunk of contiguous memory if many elements are to be stored. While in the case of linked list, there is a distributed representation of elements. Elements are not stored in contiguous locations. So many items can be easily stored even if contiguous memory is not available. And compared to arrays, insertion and deletion of elements is easier in linked list as there is no need to reallocate or reorganize the whole list structure. In arrays, insertion and deletion is expensive since it involves shifting of elements, while in linked lists, there is no physical movement of data while inserting or deleting elements. We can use linked lists to implement abstract data types like lists, stacks, or queues. Now let's see two disadvantages of linked lists. First one is that efficient random access is not possible. Means we cannot access elements of linked lists by using a numeric index. And the second one is that some extra memory is required for their implementation. This extra memory is due to the link that is stored with each item. Now these are the different variants of linked lists. In this course, we'll study about these 5 variants, out of which the single linked list is the simplest one. So we'll start with single linked lists. A single linked list is made up of nodes where each node has two parts, the info part and the link part. The info part contains the list item, the actual data that has to be stored in the list. And this link part is a reference to the next node of the list. This is an example of a single linked list with 6 nodes. The info part here contains an integer value. This can be of any other type also. We maintain a special reference variable that always refers to the first node of the list, and we have named it start. This reference is the identity of the list, and with the help of this reference only, we can access all the elements of the list. We have to use the link value from each node to go to the next node. We start at the first node and we can move from one node to the other by following each node's links. So if we just know this reference start, we can go to any node of the list. Now in Python, we have a special reference value called none. So if the link part of a node is none, it means there is no next node. No next node means end of the list. In this presentation, we'll denote a link that is referring to none by using this shaded box. So we use none to denote the end of the linked structure. This is the last node of this list, so its link part is none. For an empty linked list, the reference start will be none. Now let's see how we can implement a single linked list in Python. This is the class node that represents a node of a single linked list. This attribute info represents the actual data that has to be stored in the list. And this attribute link will refer to the next node. In this init method, info is initialized with this argument value and link is initialized to none. So whenever we create a new node instance, info will be initialized to the value that will be sent as argument and link will be none. Now this is our single linked list class. This attribute start refers to the first node of the linked list. So each single linked list instance will maintain a single reference to first node of the list. In this init method, we have initialized start to this special reference none. We can see that the list class itself does not contain any node objects. It only contains a single reference to first node of the list. In the next few lectures, we'll develop all the methods of this single linked list class. So right now you can make a new Python file and write this node class and single linked list class. As you proceed through the lectures, you can replace these past statements with the real code. So first we have this init method. Then this method display list that will display the elements of the list. Then this method count nodes that will count the number of nodes in the list. This method will search for a value in the list. This method will insert a new node in the beginning of the list. And this will insert a new node at the end of the list. This one creates a list. Then this method will insert a new node after a given node. This method will insert a new node before a given node. And this one will insert a new node at a given position. This one will delete any given node. This one will delete the first node of the list. And this one will delete the last node of the list. This method will reverse the list. Now these two methods will sort the list using bubble sort. This one by exchanging data and this one by exchanging links. Now these methods are for inserting, detecting and removing cycle from a linked list. Then these two methods are for merging lists, and these methods are for sorting the list using merge sort. Now this is the end of the single linked list class. Now here we have created a new single linked list instance object. Currently there are no items in the list because in the constructor we have initialized start with none. Now with the help of this method create list, we'll create a single linked list, and then inside this while loop we'll perform various operations on the list with the help of all the methods of the single linked list class. Now in this while loop, first we are displaying all the options, and then depending on the choice entered, we call a particular method of the single linked list class. So if 1 is entered, we'll call this display list method. If 2 is entered, we'll call this count nodes method. So we have options till 18. In 19th option, we break the loop. So this is the code that tests all the methods of a single linked list class. In the next few lectures, we'll develop and test all these methods of this class. So before watching the next video, please make this Python file, and after every lecture, you'll be able to code 2 or 3 methods on your own.